Okay, in this video we're going to talk about something known as the difference quotient. And the difference quotient is a formula in order to determine an average rate of change. An average rate of change. So every time you hear the term average rate of change, it is synonymous with the difference quotient. So let me go ahead and draw a demonstrative of what we could expect to see when we apply the difference quotient. So let's go ahead and say that I have a function and it curves up like such, and it continues on in such a facet. If I were to draw a straight line through this function, notice here it is touching twice. So the red line is a secant line, because it intersects the graph twice. So I'm going to state that at this original point here, x, I have x. The corresponding value on my y will be an f of x. So it'll be the functional value at x, and then I'm going to have a value on the y-axis of an f of x. If I travel a distance h, so from here to here, I travel a difference h. In terms of x, this next point will be x plus h. Because I had my value of x, I added h, so I have x plus h. And that means that this value will be f of my new x value, which is x plus h. So it doesn't matter what it would be, it's just going to be an x plus h. So again, this is just a formal way of writing these points. So if I were to look at these 2 points, this point right here is is x, comma, f of x. And this point right here is x plus h, comma, f of x plus h. So I know that seems a little long for 2 points, but there are 2 points. So let's say that we want to find the slope between our 2 points. So we always know the definition of slope is equal to y2 minus y1 over x2 minus x1. So we're going to have our 2 points, and I'll write them over here so we see them. We have x, comma, f of x. And then we have x plus h, comma, f of x plus h. So this here is my x1, this is my y1, this is my x2, and this is my y2. Plugging in, I'm going to have y2, which is f of x plus h, subtracting my y1, which is a value of f of x, all over x2, which is x plus h, minus x1, which is a value of x. And notice here, I'm sure we see how the x's in our denominator cancel, and we are left with f of x plus h minus f of x all over a value of h. And this, ladies and gentlemen, is the definition of our slope between these 2 points, and this is equal to, or this is known as, the difference quotient. So anytime we want to find an average rate of change between 2 points, we can apply the difference quotient. So let's go ahead and see how we can apply our difference quotient in an example. So let's go ahead and say we have an example. We'll say given f of x is equal to 3x plus 5. Apply the difference quotient. So when we apply the difference quotient, we know the definition is going to be f of x plus h minus f of x all over h. The first thing I like to do is I like to find f of x plus h. I like to do that over here on my right. And notice everywhere in f, I see an x. I plug in x plus h. So I'm going to have 3 times x plus h plus 5. Distributing out my 3, we're going to have 3x plus 3h, all plus 5. So now I'm going to have 3x plus 3h plus 5. That's my f of x plus h. And now I have to subtract. And everywhere I see subtract, I'm thinking I'm going to add an extra set of brackets or parentheses to make sure that I don't make a mistake and forget to distribute my negative. So now I'm going to subtract my original function. My original function is a value of 3x plus 5. And this will all be divided by a value of h. And this should, this should actually say apply the difference quotient formula. So apply the difference quotient formula. So I should actually have that in the instructions. I'm sorry, I left that off. So now be careful because this negative has to be distributed to both that 3x and it has to be distributed to that 5. So this will give me 3x plus 3h plus 5 minus 3x minus 5 all over a value of h. And notice my 5's cancel, and my 3x and my negative 3x cancel, and this gives me 3h all over h, and notice my h's cancel, and I'm left with a value of 3. And I'm going to put a little note here. The first note is that f of x should always cancel. And notice this part here, let's see if I can do that. No. This part was my original f of x. This part was my f of x. This was my f of x. The first note is that f of x should always cancel. If it doesn't cancel, go back and check your work. And my second note that is important is that the h will always cancel in the denominator. And notice that is what happened right here. That's what happened right here. So the h canceled right there. So that way we know that we're on a good path. Let's try one more example and see how we do. So we'll say, in this example, we'll say given f of x is equal to 2x squared minus 3x plus 1, determine the difference quotient. And we could also ask to determine the average rate of change. So there could be different ways this question could be set up. However, they mean the exact same thing. The first thing that I always like to do is that I always like to write out my difference quotient to make sure I do not forget my formula. It gives me sort of a plan of action, so that way I don't fall off my plan. I like to look at my formula while I am developing the difference quotient. So it does help me. I recommend everyone writing it out every time they see a problem because it will make a difference regardless whether or not your instructor allows the use of the difference quotient on their exams or not. So first step is that we'd like to find f of x plus h. So everywhere in f I see an x. I'm going to plug in x plus h. So I'm going to have 2 times x plus h squared minus 3 times x plus h plus 1. Be careful here. 2 times x plus h squared is really 2 times x plus h times x plus h minus, I'm going to distribute this 3, minus 3x minus 3h. Be careful about the h there. It becomes a minus 3h, still plus 1. And now I'm going to FOIL out this x plus h squared. So I'm going to have 2 times x is x squared. X times h is plus xh. H times x gives me plus xh. H times h gives me plus h squared. And this will be all in a bracket. And I'm subtracting off 3x and a 3h, and I'm adding 1 at the end. But now I'm going to combine any similar terms. And I realize in my bracket I have xh plus xh. That's going to give me 2 xh's. Plus h squared, all in a bracket, minus 3x, minus 3h plus 1. And now I have to distribute my 2 to every single term in this bracket. So this will give me 2x squared plus 4xh plus 2h squared minus 3x minus 3h plus 1. So this is equal to f of x plus h. So I have my first part right there. So now let's go ahead and apply our difference quotient. So we're going to have 2x squared plus 4xh plus 2h squared minus 3x minus 3h plus 1. I'm going to subtract my original function, which is going to be the original function, which was, I believe, 2x squared minus 3x plus 1. So we're going to subtract off 2x squared minus 3x plus 1. And remember, our first hint is that that guy should cancel out. So when we distribute that negative, we should expect f of x, my original function f of x, to cancel out. So this will give us 2x squared plus 4xh plus 2h squared minus 3x minus 3h plus 1. Distributing our negative to all three terms, we're going to have minus 2x squared plus 3x minus 1 all over a value of h. Let's see what happens. So notice here, the 2x squared and the negative 2x squared cancels. The negative 3x, the positive 3x cancels, and the 1 and my minus 1 canceled. So this right here was my original function f of x. And notice it canceled out, which is what we expected or what we wanted. So now we're going to have this equals to 4xh plus 2h squared minus 3h. So we have this term here, we have this term here, and we have this term here. And this is still all divided by a value of h. So let's go ahead now and factor out an h from our numerator. So we're going to have an h times the quantity of 4x plus 2h minus 3. And this is all over a value of h. So we factored out an h from that numerator. And notice now we see that these h's cancel, and that's that second indicator that we are on the right path. And this will give us 4x plus 2h minus 3. And this is the applied difference quotient for that function.